Okay, we continue. Continue. Just now we go for central impact, and we stop at this coefficient of restitution. So coefficient of restitution is you take velocity after divided by velocity before, and you always take big number minus small number. Okay. Now we look at oblique with its two objects come into two different directions, and after impact, two objects go different another two more direction. So for impact question, always start with your axis or line of impact on the plane of impact. So you draw the x and y line, and then you label the angle of theta 1, theta 2, and phi 1, phi 2. So all this you have to establish before you continue analyze the question. You have to know the velocity and after. Mass do not change. Mass of A and B do not change. So initial velocity usually will be given. So you have 4 unknown in the question. What I mean by 4 unknown? You have velocity after for A and B, and also you need to find the angle after impact for oblique. Okay, so for oblique, you need to draw the diagram of this one. Means the impact diagram, the line of impact, and also the plane of impact, velocity in and velocity out, and the angle change of that two. Okay. Then you solve your question by looking at individual balls or individual object. You break the vector or the velocity vector into x and y. Yeah, the step will be you draw the whole impact diagram. Next step, you draw individual object and then break all the vector velocity before and after into x and y, and you put in the principle of linear impulse and momentum diagram. As you can see here, momentum before plus impulse equal to momentum after. So actually it's mv plus integration of f dt equal to mv2. You put into this diagram. So you draw VA, MV, break the velocity into x and y. With this one, you break into this V into x and y. And then the impulse F dt. And then A is depend on your estimated direction. So this one is going to the left with the angle, this one. So that's why the arrow is pointing up and to the left. You repeat the same for B also. B is this ball on the right. Before is going to the top left. So you break into X and Y. That's why you get this arrow to the left and going up. You break this arrow up and down. Plus impulse. Be careful on the arrow. You imagine you are that ball. What do you feel? Ball B is pointing inside from left. If you are B, you feel something hit from your left. So arrow pointing to the left. Same with A. If you are A, you feel something pointing from your right. Important is arrow during vector. So same with B. B after is here. Split into right and top. Once you understand this one, the rest is just solving simultaneous equation. Any question for this one? Okay, we stop for a while. Ustaz, Okay, we continue. Okay, so if you look at the question and you look at the diagram, what motion you have? Do you see curve? You see curve motion? So there's a collinear motion. So what collinear motion? You have to call back all the collinear motion equation. You have the AN, AT, and so on. But it depends on the question. You need to stand by. So you have the mass given, release from rest. So you have your V1 or V0, V1. So V0, V1 is 0 at position 0 here, at here. So after falling 90 degrees, it will hit B and two objects move together. If the coefficient of rotation is given 0.5, so if you are given the E, means you need to use the equation for E. Determine the velocity of the back and the box just after impact. What is the loss of energy during collision? Okay, so you have to identify what kind of impact it is. Does it oblique or does it central impact? Okay, you need to identify the moment that is hit. Does it hit with a different angle or does it hit in the line of impact? Along the line of impact. This one is like along the line of impact, so this is central impact. So in central impact, you can draw the diagram A and B like that, plane of contact, velocity, VN and VB. Right? So on your left, your B will be the sandbag, your A will be the box. So basically your box is stationary. So you know your VA already. You know your VB. VB you need to find, but you can find. You can find the VB from the principle of linear impulse and momentum. Okay. So, first step, you have to know what kind of impact, oblique or central. So this is central. So you need to draw the motion. You need to establish your own datum, which is on the top, and it swing down 1 meter. So you draw free body diagram, put in the mass, effect of mass with this W. W always go down. Okay, W always go down. So scenario 0 to 1 or 1 to 2, depend on your preference. So on my slide, I put in before as 0, after as 1. You can put 1 as before, 2 as after, depend on your preference. But be consistent, be consistent. Once you have the diagram, then you use conservation of energy. Okay, when do you know you can use conservation of energy? When you see the question mention the word no loss of energy, loss of energies, and so on, then you can pull out conservation of energy. Okay, conservation of energy means you only consider 3 types of energy. If there's a V, then there's a kinetic, there's a change of height, there's a potential, there's a spring, then there's a spring energy. Here you don't have spring, you have velocity, you have height. So you have potential and kinetic. So conservation means what you have before will same as what you have after. So you write T1 V1 equal to T2 V2 or T0 V0 equal to T1 plus V1. And then expand the equation. Okay, if you forget or if you don't know how to write this one, you can write in sentence. You can write kinetic energy before plus potential energy before equal to potential energy after plus potential energy after. Then you write equation. T will become half mv squared. And potential will be mgh, or you can write wy or wh. Okay, it depends on your diagram. If your diagram don't have mg, you use w, you have to put w. Depend on your diagram. So you look like this. Okay. So you change the kinetic equation and potential equation. Okay, what is important is conservation of energy. Then you pull out, expand the equation, and then you just substitute the value that you know. Always establish the general equation, then change the equation, expand, get the general one, then you substitute. Once you substitute, you'll find there's unknown that you can find. So before velocity, start from rest, V0. So kinetic 0. And this one, you start from datum, H0. Start from datum 0. And then this one, mv square. You don't know the V when you're hitting. H here, actually, I have a careless mistake here. It should be negative. It should be -1 and not +1 because it's below datum. Here, I have one careless mistake here on my slide. There's a error there. Okay, if not, you cannot get positive value. Velocity will be positive value 4.4. So what mean by positive? It means you go to what direction? That direction. You have a curlinear motion, always tangent direction to left. Okay, you have your VA already. Once you have VA, you can find other things. So VA, you want to find velocity of the bag and the box just after impact. So you have the velocity at this point, VA. So you can draw the diagram when they hit, what happened to the two objects. So A will be here, box will be here. VB is stop. VB is stop. And then you only look at this scenario. Forget about the previous one. The previous one is another set equation already. This one is one scenario. So you focus on this scenario. So just before impact, you have the velocity of V in this direction, X direction. Because it's tangent, it moves in the tangent collinear motion. VA 4.4. So you call out conservation of momentum. So after impact, we assume AB move together. Before impact, okay, after impact, move to the left. So you have the two objects move in the same speed. So we have two objects move the same speed. What happened to your equation? You have to take M1 plus M2 and then V on the right hand side. So you have VB2. But it will be the same if they move to this one. Or sometimes, because the question do not mention the two objects coupled together, we assume both have different speed. We assume there's a scenario where two objects will able to split. It can be bounced back sometime. If the object do not mention the assumption that is coupled, then you assume it break away two things. So that's why on a diagram, we have different velocity for A and B. So we establish the conservation of momentum. Momentum before equal to after. So you have MVA1, MVB1 plus MVV2, MVV2. And positive direction is to the left. To the left, because we are dealing in vector, is important. All the direction to the left is positive. So you put in the value. VA, MA you know. VA you already know. VA before it hit is 4.4. VB before it hit is do not move, so 0. After you look at the diagram, you don't know the VA2, you don't know VB2. You don't need these two. However, you have two unknown. However, you are given the E. There's a reason why I give you the E. Is to solve this VA, VB and solve simultaneous equation. Okay, so start from here. You already know what to do already. After this, you call out the equation of E. You get another equation. Solve simultaneous equation. Yeah, coefficient. So here, after it hit, VB will be move faster than VA, which is the same scenario as our slide. We can directly apply the E equation. Yeah. So if the scenario you hit before A is faster, B slower. After hit, B go faster, A slow down. You can use this equation directly. So E equal to before velocity after divided by velocity before. You take big number minus small number. So VB minus VA, you don't know, but you know the E is 0.5. VA1 is this one, 4.4. VB1 is what? VB1 is what? 0. Because the box do not move. Then you solve. You have two equations here. Solving simultaneous equation. Okay, the rest I do not, I won't go deep into there. I assume you already know how to solve mathematics. From there, you already know your VB2, VA2. Yeah. So solve these two equations. Your homework. Okay, you have these two equations, you solve. You will get these two answers. You will get negative value. Negative means velocity go to the right. It's the same meaning. It's the same meaning. It's just that negative, it means your diagram is drawing like this. But you get negative means it's going that way. VB also same. VB is this number, 1.66, going to the left. It means after impact, the sandbag will bounce back. In this case, you should able to describe the scenario or the motion after impact. So if you calculate after this, you get negative. then you need to look at your diagram. If it's negative, means the arrow flip already. VA, the A will bounce back. However, B will continue to move to the left. Yeah. So the rest, I will just let you go and do your homework, the mathematics part. Okay, once you have this value, VA and VB, the question asks you loss of energy. Loss of energy, basically you use conservation of energy before equal to after. So you have T equal to work. This one is chapter 3 question. Energy plus work equal to energy after. You use principle work and energy to solve. So recall this is chapter 3 equation. Energy plus work equal to energy after. So you just substitute. Kinetic 2 minus kinetic 1. Because you have two objects, so you have two kinetic term there. You have object A and object B. The front one, half 9, 1.66. This one is for object B. This is object A. But there is a careless mistake there. I should put negative 0.554 here and not positive. And then you bracket it square. Yeah. So there's a careless mistake in my working. In this case, I assume my direction positive to the left. So in my working, I should show bracket minus 0.554 because my value for my VA2 is negative in my previous calculation. But we have a square there, so we still get positive value. Okay, so this one, the second term, this one, before y the only have one term because the box do not move. V for the box is 0. So half mv square. What? There's a square missing here also. Okay, there's a square missing there. My careless mistakes or my typo error there. So these are the careless mistakes that usually happen in the test. You know what to do, but some labeling you forget to put inside there. Okay, the final answer is minus 16.6 joule. This is the loss of energy. You get negative, it's loss of energy. You get positive, you gain energy. Yeah. Any question? So this is just a recall of chapter 3, principle of work and energy. Okay. Okay, energy loss happen because of inelastic deformation during corrosion. Okay, this one we go a bit fast. I just show you how to solve when you see this kind of question. This one is oblique impact. Oblique impact, you copy the question. You have the velocity coming 30 degree. You have velocity coming in 45 degree. When you see this one, you call up principle of linear momentum and linear impulse and momentum. Work in x direction and y direction. So you have four equations. One, object A, you have x direction and y direction, linear impulse and momentum. For B, also you have two set of equation, principle of linear impulse and momentum for x and y. So what is important, you break the velocity into x and y first. Break the velocity into x and y first. Determine your x positive direction and y direction. Then only you substitute inside the equation. right? So the rest mass is given, E is given. So when every time you see E is given means you need to recall the E equation and solve simultaneous equation again. All right. And sometimes it asks you to find resultant of the velocity. Means you square plus square root the answer. Okay, so I go very quick. Go very quick. Identify is oblique. Then you break your velocity into x and y. Who don't understand how to do sine and cos? Okay, so if you get negative, then you should put in negative. Yeah, you should know why is negative. For example, VB1x, this one. Your x is going to the left. That's why negative. Your y also going down. Your y go up positive. That's why the value is negative. So from here, you should already establish whether it's positive value or negative value. Your x and y vector for velocity. Once you have this one, you call out the equation. Okay, for unknown. So you draw this diagram. You draw this diagram. This diagram actually represents principle of linear impulse and momentum. Momentum before plus impulse equal to momentum after. One in x direction, one is y direction. For one A, one a B, and then you combine the vector. What is different is you put in the x and y vector there. Yes. Okay, so when you hit, right, A feeling something from the from from that direction, that's why it's like this direction. Equal we don't know yet, but we assume. We don't know where does it go, but we assume go to this direction first. We assume first. We don't know the angle first. Uh, yeah, of course you can draw. Okay, this one, you can draw to the left and go down or go up. This one, there's no fixed there's no fixed rule that you must draw like this. No, but we assume that this is our assumption. So means when you calculate later, you get negative, you just flip the arrow. Because you combine the resultant of VAY and VAX, you get the angle of that vector. Of course, when you hit like this, you know A will go this way, this quadrant. So, but this is just an illustration, just to show you what to do. But of course, okay, if you can assume, then you follow your diagram. This is a textbook example. This one. This one also same. This one actually you estimate. This is what textbook estimate. So if you already can estimate, let's say A will go to this quadrant, then you draw accordingly. If you go to this quadrant, so this one will go up and this one go to the left. If you assume B will go this way, then you change this one and this one go down. Okay. The reason of textbook putting this direction because it intend to get positive answer. Because go up positive, go to the right positive. You want to get positive value. Yeah. Okay, now, so don't confuse yourself. This one is assume the positive direction to the right and go up. After you do analysis, if you get negative, you flip the angle, flip the arrow. If you already assume the direction and you get positive, means your assumption is correct. Yeah? Understand or not? Understand? Who is confused? If you assume, I write something on the slides. If you assume A go this way, B go this way, then your resultant then your A will go this way and this way. B will go this way and this way. Your diagram for this one, you can draw like this and like this. And this one, you can draw this one and go down. And then after your analysis, you get positive value for VAX2, VAY2. You get positive, means what you draw in the red arrow is correct. Okay? If you get negative, means you need to check whether logic or not. Sometimes it's because of your when you move, you forget the negative sign and so on. So that's why you get the thing. Okay, the rest just substitution. You use conservation of momentum when you have oblique. You always use conservation of momentum where you take out the impulse. Momentum before equal to after. You solve for x direction, positive x direction to the left. So you put in the answer. VA positive to the left, which is correct. VB to the right. This one. To the right, negative. VA 2, you don't know. VB 2, you don't know. You get the first equation. This is for x direction. You do for x. You do another set for y. X. You do x first. Then you have the constitution. Okay, this one is assume. It assume directly the velocity go to that direction. V go to that direction. Okay, VA go to that direction. VB2 go to VBX go to this direction. Both go positive direction. Again, if follow your diagram, if your diagram point to the another direction, it should be negative here. So here you call out the coefficient of restitution before velocity, after velocity divided by before velocity, and we assume after impact, B will go faster, A will go slower. So BV2 minus slower value, A1 means before A move very fast, minus a small value of B, B1. You substitute, you get another question, solving simultaneous. Equation 1, equation 2. You need to polish up your simultaneous if you're weak, because in dynamic, as you can see, we are only reached chapter 4 and you keep seeing simultaneous solution. Okay. So solving 1 and 2, you get these two answers. When you solve these two equations, you get AX 2x minus 1.26, which is agree with our earlier estimation, right? So A will bounce back to the second quadrant of the axis. VB2x is positive. Agree with what we estimate. Yeah. You do the same Okay, this one. Okay. Once you have this one, okay, this is x direction. You solve for x direction. You do one more for y direction. This one become y, this one y, this one y, this one y. You substitute the y value that you solved just now. All this value, the y, substitute inside. Solving the equation again. Yeah, solving. In this case, we take out the VB. VB, yeah. Okay, so this is how you solve for y. Okay, you solve for y. Yeah, you read from my slides. This is all mathematics. Okay, once you have all the component, the vector v, sometimes the question asks you to find resultant. Basically, you redraw the vector diagram and then find resultant. By using resultant equal to x squared plus y squared, square root. Angle is the tangent of y divided inverse tan divided by y over x. Okay, you will get this final answer. This is involved trigonometry. Okay, I skip a lot of steps here, but basically we are calling out the resultant and trigonometry. Okay. Our time is until, oh, we overshoot already. Okay. Okay, we stop here. Next class we go angular momentum.